See why the cavity radiation was important. So the cavity was of arbitrary shape, and what we see from the outside world is the radiation emitted by the hole. But the radiation emitted by the hole is comprised of the cavity. So we instead of considering the radiation emitted by the hole, we can consider the radiation enclosed by the cavity. So the cavity was of arbitrary shape, so we can, for simplicity, assume the cavity to be a cube of length A. So for simplicity, we can assume this cavity to be a metallic wall. Now if we see that if you imagine any kind of electromagnetic wave inside the wall, we can see that the radiation inside the wall is like going from this direction to that direction, is reflected in the wall, is again going to that wall, is reflected back to and fro. So what it gives rise to is the standing wave. In all direction, in all the walls, there will be standing wave in all the three directions. So all the wall are like perpendicular. All this wall are perpendicular to each other. So what we have considered here is a perpendicular axes are the perpendicular. So this allow us to consider the radiation or the standing wave in a particular direction, because standing wave in a particular direction is completely independent of the radiation or the standing wave in its particular perpendicular direction. So for simplicity, first of all, we can, this is the artificial case, that is one-dimensional cavity. There is nothing called one-dimensional cavity in a practical life, but we can consider it because we can analyze a one-dimensional case as the axes are perpendicular to each other, walls of the opposite side are parallel to each other. So the three components of the electromagnetic wave or the radiation do not mix, so we can consider it separately. Now we will consider the equation of a standing wave, that is E naught sine kx cos omega t. This is the equation of standing wave. This is the amplitude of the electric field corresponding to the standing wave, and this is the amplitude. Okay, this is the amplitude at time x and space x and time t. Now we can write it as E naught sine twice pi by lambda x cos 2 pi nu t. One more thing, we have assumed that the wall of the cavity is metallic. So what is the nature of a electric field in a metallic wall? So if we assume that there exists some kind of electric field, so radiation is nothing that is comprised of electric and magnetic field. For simplicity, we are considering only electric field. So if instead of note some displacement of this electric field exists in a wall, what will happen? So this is a displacement. So in metal there are lots of electrons available, so electrons will move in the opposite direction to give rise to some electric field in the opposite direction of the strength, so that will cancel out each other. So in any way we will get a node in the metallic wall, in any wall, any of the wall. So we have got two boundary condition, that is the displacement is 0 for x equals 0 and x equals a for both the cases. Now we will consider the boundary condition for x equals a. For x equals a, the displacement will be 0, that is sine twice pi by lambda a is 0, that will be twice pi a by lambda will be n pi. So what we'll get is pi cancels out, then lambda is there, that 1 by lambda is n by twice a. Lambda can be written as c by nu, so nu is equals to c by nu and c by twice a, where n is a natural number, so it belongs to the set of natural number. Okay, so why now we need to calculate, like in the spectral redundancy we had this term d nu, if you remember. So we need to know the number of standing wave lies between the frequency from nu to nu plus d nu. So how we calculate it? For calculating, we just imagine the real axis line starting from 0, 1, 2, 3, 4 goes on, and this is the n. We had got the relation, that is mu equal nc by twice a. We can write in another way, n equals 2a mu by c. So what we need here is a quantity, that is the number of allowed frequency in the range from nu to nu plus d nu. We call it n nu, and is a function of the frequency. So if you see here is that distance of any point from the origin d is nothing but 2ac nu, because d is a natural number. From this equation, n is twice a by c nu. So we consider another d, that means d2, and d will be equals to twice a by c, and d nu is the nothing but the number of allowed frequency lies between these two intervals. If you consider, we will note it d1 and d2. So what is d2 minus d1? Basically that is 2a plus c into del nu. So what is d2 minus d1? d2 minus d1 is the number of allowed frequencies between this range. So we had already called term is as n nu d nu twice a by c into d nu. So this is the term we were searching for, but we still need a modification here. This is not the term, the final term, because this corresponds to only one kind of polarization. For any electric field there exists two kind of polarization. For the other kind of polarization we still need another two here. So for final d nu n nu d nu is 4a by c d nu. So this is the number of allowed frequencies in one dimension. We have to still calculate the number in 3 dimension. For that we will draw another diagram.